Today we study electric dipole. Electric dipole, this is the different feature of electricity because in electric charge is either positive or negative. If we combine two charges together, first let us consider charge Q is placed at some point, and potential at a point with distance r is V monopole. Is over a vector and charge Q over distance, right? In case we have two charges with one is positive, the other is negative with the distance d. So let me choose the central point and at distance r. This is the origin. Potential is charge Q over R, and if D is much less than, smaller than R, then it is just almost same as R, and the potential due to the negative charge, it is additive, minus Q, so it is 0. Monopole contribution vanishes. However, it is not exact formula, this approximation. If we consider the exact relation, it is actual distance from the field point to the positive charge is R plus, and I have half of D origin and another half of D. This distance is R minus, and the distance distance that we have used is R. That is different. They are different. So exact relation is equals R plus, and let me move this one. Minus. So 1 over R structure cancels, but it is not exactly 0. We will find that it is proportional to 1 over R squared. If the potential is proportional to 1 over R squared, then electric field is proportional to 1 over R cubed. In the monopole case, potential is 1 over R and electric field is 1 over R squared. It follows the inverse square law. Because this charge can be negative, it's possible. But what happens if I have mass? So gravitational potential is always positive definite. So the sum of two contributions never cancelled, and the gravitational field is still depending on 1 over R. Potential is 1 over R, and the gravitational field is 1 over R, proportional to 1 over R squared. So in order to study this, we need to expand this full relation, full formula So let us find what these r plus and r minus are. First, let me define this one as d vector, displacement vector d, and this is r. So r plus vector is, this is r, and this is r plus vector. So this is 1/2 of distance. So we find that r plus 1/2 d equals r, or r plus vector equals r minus half of d. In the same way, the vector r minus is this one plus this. So r minus vector equals r plus half of d. Okay, r plus vector is r minus half of d. R minus vector equals r plus half of d. Okay. What we are interested in is pulling out this charge q, the difference between one of r plus and one of r minus. So what is the magnitude? R plus magnitude is the square root of r plus dot r plus. So that is square root So if we expand them, r squared minus 2 times d dot r, because 1/2, and we have d squared over 4, 1/4 of d squared. I'd like to know the dependence of d when d's magnitude of d vector is much smaller than r vector. Then we can make an expansion. So it is just, I can pull this one r out, and this is 1 minus okay. In the same way, I can compute r minus to be, because d is replaced by minus d, I find that these two are the same for these two pieces, so it's better to write it as 1 plus minus d dot r, r squared, and this is r, 1 plus d squared divided by 4r squared minus plus d dot r, r squared. So, okay, so if I pull this out, r plus minus is actually, I can pull this one out too, r square root 1 plus 4 d squared over 4r squared multiplied by 1 minus 1 minus delta, where delta is d dot r divided by
plus minus.
sorry?
I plus minus.
Minus plus. Okay. So let us continue. One over square root 1 minus delta. This delta is a small quantity. You know, this is scaling behavior is a d times r divided by r squared. Neglecting d squared over r squared, it is proportional d over r. This is a small number. So I can make a Taylor series expansion. This is 1 minus delta, and power is like that. If 1 plus small number n is 1 plus n delta plus n minus 1 1/2 delta squared. We can expand like that. So this one is 1 plus 1/2 delta, and then n minus 1 delta. Okay, so the answer is I have 1 plus half delta, and it becomes positive 3/8 delta squared plus order delta cube. Okay, I have 1 plus, then replace delta by minus delta. Then I have minus half delta. They are the same. So, what we are interested in is 1 over r plus, that is proportional to 1 minus delta. So, subtracted by this one is leading contribution vanishes, and this guy is delta, and this contribution also vanishes. So vanishes plus order delta Q. That is small quantity. So let's see if our delta is here. Okay. Erase. Potential for the dipole, charge Q 4 pi epsilon 0, and over factor was what was the over factor? I raised R square root, right? That's right. And then substitute this one. And the result is delta. Plus order delta Q. So delta was scaled by d over r. So what about this term, contribution? This one, if we expand this, this will increase the power of delta by square. So higher order contribution. If I expand this again, it contributes to the delta squared or higher in addition to this power. So they are all, this contribution and this contribution are related to higher order contribution. So this is Q over 4 pi epsilon 0, just 1 over r, and d dot r over r squared. So we can replace this one by r hat 1 over 4 pi epsilon 0, and becomes it is r squared qd vector times er hat. Alright? So we call this one as P, not momentum. P equals Q times distance between the two charged particles. So electric dipole moment. Then potential is proportional to 1 over r squared. Okay? Potential is 1 over r squared. So in the next page we will check what the electric field is by taking the derivative minus gradient. Okay? The most important thing here is if there are two contributions with different sign and the two charges are the same, if you combine these two, this whole object is chargeless. Plus Q and minus Q, that cancels. So monopole contribution cancels, but if you look into the structure in detail, there is a charge distribution with positive and negative charge. Although the monopole contribution cancels, this dipole structure, plus Q and minus Q, survives, however, with higher power in the denominator. So if we are placed at a distant point, distant enough, much bigger than the distance between the two charges, if the r is much bigger than the distance between the two charges, you can see the monopole structure cancels, but still there is electric field that is much weaker than this one, with the potential, with the additional power in the denominator. So dipole contribution at large distance, dipole contribution vanishes very quickly. much more quickly than the monopole contribution. So electric field will be proportional to 1 over r cubed instead of 1 over r squared. Okay, that's it.